This tutorial describes false position implementation, and it's very similar. The implementation is very similar to bisection method as it was described in the tutorial or the manual, that the only difference in the implementation is how the new value of the root is computed. In one case we are just finding the midpoint, whereas in the other case we are interpolating by connecting 2 points on the curve. So um, go back to your bisection method code and just save it as a new file. Save as, and we will call this false position. Okay. So this, and now we will just make a couple of changes in this code so that we can remember that this is not bisection method anymore. So what is the difference in this method and the bisection method is the where we update and find the new value of the root. And as you can see, we will be implementing this equation instead. So this will become yu minus the value of function at yu times yl minus yu, and then divided by the function of the function value at yl minus function value at yu. And now this is it. This is false position method implemented already. Make sure you look at the rest of the code and try to understand how this is related to the bisection method. And if you have missed something in the last tutorial, make sure you'll understand that. So again, we run it and we can see that it achieved an answer of 1.5353 with an error of 0.09 in 61 iterations. It looks like in this particular example, the convergence of the false position method is much slower than the bisection method. So in this case, bisection method is getting faster to the result compared to the false position method. So that concludes this tutorial.